Welcome to the class, my dear students. In today's lecture, I am going to explain you about some more problems on normal distribution. This is the continuation of the previous problem. In fact, let us say that if x is a normal random variable with mean mu is 3 and variance is 16, suppose, then find the probability of x lying in the range 2 to 7. So here what was given? Mu is 3 is given and variance is 16 given. Variance is 16 means what is the standard deviation? Square root of 16, which is equal to 4. And now we are going to find out what is the value standard normal variate when x is equal to 2. So what is the formula for z to find out the normal standard normal variate? Z minus mu by sigma. Sorry, x minus mu by sigma. So z is equal to x minus mu over sigma. What is x here? It is 2 minus 3 over 4. So it is minus 1 over 4. That is the value given by minus 0.25. Right? Now we are going to find out when x is equal to 7, what is the standard normal variate. That is equal to x is 7. Mu is 3 and standard deviation is 4. So it is 4 over 4, which is equal to 1. So what you can understand now, the probability of the normal variable x lying between 2 and 7 is same as the probability of z, the standard normal variate, lying between minus 0.25 and 1. So this is what now we are going to find out. Let us look at the figure now. Under the normal curve, the value z is equal to minus 0.25 is somewhere here and z equal to 1 is here. So in between these two, we have to find out the area. Now this is the area. So how to find out this area? This is nothing but the probability of from negative 0.25, negative 1 by 4, that is negative 0.25 to 0. Plus the probability of 0 less than z less than 1. Correct? Now since the function, this is the probability distribution, the normal variable, the normal curve is symmetric, I can rewrite this as the from 0 to minus 0.25 is how much area is the same as 0 to 0.25, because in our standard normal distribution table you will get from 0.25, not the negative values. So you should understand one thing, that the area between from left to 0 is same as the area from 0 to right. That means minus 1.4 to 0 is same as 0 to 1 by 4, and 0 to 1 by 4 you will get by using the standard normal table. So this is given by probability of 0 less than z less than 0.25 plus probability of 0 less than z less than 1. So this is what you get. So now let us find out what is for the probability for z lying between 0.25. That means from 0.25 means where it is, let us say this is 0.2. So you have to go in this region. 0.25 means 0.8987. Am I right? 0.8987 is the answer. So we have to find out the standard normal distribution here. What is that? 0.8987. Let us write down that. 0.8987. Okay. And now this is given by 0 to 0.25 is this much, and probability of z lying between 0 and 1. That means at 1, what is that you see? At 1 it is given by, at 1 it is 0.3413. So let us now find out 0.3413. So this is 0.3413. So this is what the probability of z lying between 0 and 0.25 and 0 to 1. So it is given by, it is 0.0987, right? It is 0.0987 plus 0.3413, and that gives you 0.44. Correct? So this is what the area from minus 0.25 to z is equal to 1. I hope you could understand now. Let us now go to the next problem. The speed transfer from a server on a campus to a personal computer at a student's home on a weekly evening is normally distributed. Okay, with the mean of 60 kbps and standard deviation is of 10 kbps. So now find the probability that the file will transfer at a speed of less than 70 kbps, less than 70 kbps. So it is less than 70 kbps. Let us now change it. It is less than 70 kbps. So the mu is given as 60. So write down mu as 60 and standard deviation is 10. So sigma is equal to 10. And we have to find out for less than 70 kbps what is the probability. So probability of x less than 10 we have to find out. Okay. Now for less than 10, what is the standard normal variable? First of all, we have to find out. So z is equal to what? X minus mu over sigma. Now what is x? X is given as 70 minus mu is 60 over sigma is 10. So it is 10 over 10 and that value is 1. Okay. So what is the probability of x? Less than 70 is over now. Now we will find out what is the probability at x is equal to 8. What is the standard normal variate when x is equal to 8? So if x is equal to 80, it is given by 80 minus 60 by 10, that is 20 over 10 and that is equal to 2. So what you can understand now, the probability of the normal variate lying between 70 and 80 is same as the probability of the standard normal variate lying between 1 and 2. You could understand now, right? So this is what the region now we are going to find out. In between 1 and 2 we are going to find out. So let us see now what it is according to this problem now. For less than 70 it is first we have to find out, and what is that probability? What is the first question? We will now solve it and then we'll go to the next one. Okay, when x is 70, so we need to find out what is probability of x less than 70 is same as the probability of z less than 1. Okay, so first we will do that and then we will go to the next question. Okay, let us now see first this one. So what is this probability of z less than 1 means? This is the area and this area is nothing but first 0.5 to be added plus probability of 0 less than z less than 1. So now what is this value? Probability of z lying between 0 and 1 means what you have to say? This is the what now for z equal to 1 means here it is 1 means 0.3413. So this value we have to write it here, 0.3413. So the value is 0.3413 and that value gives you 0.8413. So this is what the probability of x less than 10 is, 0.8413. Now when you take when x is 80, z value is 2. So this is what the second question. For probability of the x lies between 70 and 80 and probability of z lying between 1 and 2 is same. That means the standard normal variate is nothing but this one. So let us now solve this by using our figure here. So let us write down this. This is the x-axis and this is the mean. Should be in the mean, should be in the middle. And now what is the value of z1? Z equal to 0 is this much and 1 is here, 2 is here. So what is the area between z equal to 1 and z equal to 2? So what is that area? Is this area, right? So the area between z equal to 1 to 2 now you are going to find out. So what is this? How to find out this? This is nothing but from this whole thing is 0.5, right? So what you have to see is from 0 to 2 how much? Minus 0 to 1 if you do, then it will be easy. So probability of 0 less than z less than 2. From 0 to 2 minus probability of 0 less than z less than 1. Then you will get this range. Okay. From this whole range 0 to 2, if you remove 0 to 1, you will get this area. So what is at 2? What is the standard normal variable table when z is equal to 2? Let us see now. When z is equal to 2, the value is 0.4772, and at z equal to 1, it is 0.3413, 0.4772. So now let us 0.4772. So write down this 0.4772, and already we have done for z less than 1, which is 0.3413. So let us subtract this and get the value. It is 12 minus 3, 9, and then 5, and then 3, and then 1. Correct? 0.1359 is the answer. So the area covered between 1 to 2 under the standard normal variate is given by 0.1359.